I'm going to be talking about two research efforts we did as part of the MC3 project. One is around trying to understand the multitude of co-benefits with climate action, as well as trade-offs and challenges. The other one is that we use something called decomposition analysis to break down and get a better understanding of change in community emissions over a period of time. I'll explain a little bit more about what each of these mean and what each of these entail, but at this stage, I just want to mention that we approach both of these projects with trying to think about new tools and techniques that local governments can use for climate action and planning. The first one of this project that we did around climate action co-benefits, before getting into the details around the study, I think it's worthwhile just to describe what co-benefits are. In essence, climate action co-benefits are benefits that are experienced from climate action strategies that go beyond mitigation and adaptation. The example I like to use is if you make more walkable cities, then you're getting more people walking, less people driving, so that's a mitigation strategy. But you're also getting more people walking, so that's great for exercise and community health. You're also getting traffic reduction, so there's less exhaust that's going into the local airshed, which is good for air quality, which is also good for community health. These co-benefits are actually relatively intuitive when you look at them piece by piece, but there are an absolute multitude of them. And then there's benefits associated with other benefits. So what happens is if you actually start drawing the connections between the bunch of them, then you end up getting something like this, the systems model. We did this as a bit of a proof of concept project a couple of years ago where we made this relatively simple systems model mapping climate action strategies and co-benefits to show that it's a really useful perspective for doing climate action in an integrated planning sense. Climate action is more effective when you kind of do it within the broader sustainability framework. And if you actually start mapping out these co-benefits and looking at all the connections, then you can do that. Rather than just doing climate action, you can say, well, we're going to engage in climate action in a way that also does things around community health, walkability, maybe even business viability, things that meet broader sustainability goals. Co-benefits present themselves as win-win situations. I mean, why not reduce greenhouse gases and promote health? Why aren't we doing this all the time? Well, it's not really that easy. I mean, like I was mentioning, each of these individual co-benefits seem relatively intuitive when you look at them, but you get a massive complexity of them, and it's difficult to get that in your mind. So a lot of times when people engage in climate action, you're kind of getting unanticipated co-benefits. They might happen as happy accidents where we kind of want this to be more deliberate. In this case, what we want is this idea of being able to understand the complexity of all these co-benefits, which is quite difficult. Also, it's not all rosy. There are barriers to doing certain climate action strategies, and some of these climate action strategies have trade-offs to them. So it's really not all win-win. It could be win-win-lose. So in order to get a better understanding of this, what we did was engage in a study where we're trying to understand the multitude of relationships between climate action strategies, co-benefits, trade-offs, and challenges. I'm not going to go into too much detail around the methods, but I think it's worthwhile just giving you a brief run-through. Basically, what we did was took all the interview data from 2012 and 2016. We coded it, so that means that you sort of tag the different parts of the data with different themes. These codes would be classified as a strategy, a benefit, or a problem. When you look at the overlap of those codes, then you can start seeing the connections and relationships. And then when you start drawing the relationships, you get something like this. You get a systems model. We have a series of these models, and they center on different climate action strategies. And to read these models, the light blue ones are strategies in general. The dark blue ones are strategies that kind of link to other models so that you can kind of read them in concert with one another. The green nodes are the benefits. The orange nodes are the problems, so those challenges and trade-offs. And then we have these two different types of connectors. So green connectors would be positive relationships. So a strategy might promote a benefit might promote another benefit. And then we have these connectors. So a problem might cause challenges for a certain strategy, or you can think about it the other way around. A strategy might actually diminish this problem and make it more possible to receive a benefit. So as mentioned, we had a series of models. There are 7 models altogether, and I'll run through these quickly. They center on densification. So this is mitigation that occurs from the efficiencies that come from around transportation of residential energy when you densify areas. We had a separate model for mixed use and downtown revitalization. It is linked to densification quite often, right? But we have treated these as separate models because mixed use downtown revitalization is often more about form, where densification is really about that concentration. Green buildings, so that was mitigation around energy efficient and green building practices. We had one around energy innovation, so this is renewable energy and district energy. Trails and transportation, so this is around active transport and alternative transportation, public transportation. Ecological capital, so there's the benefits from carbon sequestration around fostering and maintaining green spaces, as well as those adaptation benefits such as flood control and microclimates, cooler areas as the greater climate warms. And then we had another model around waste and water. So that's mitigation benefits from waste diversion and adaptation strategies around stormwater and flood management. So I won't be able to go through the entirety of these models. I mean, there's just a lot there, but to show you a bit of an example of what's going on, this would be our density model right here. And as you can see, Green Connector benefits to land use efficiency, so densify rather than sprawl. The density model also connected with a lot of other models. There's a lot of other strategies. So developing green buildings when you densify. And also, as I was mentioning, it is linked to downtown revitalization. Density was also kind of a necessary requirement for district energy system. But then we get some of these problems that come up as well. Once again, it's not all rosy. One of the big ones around density is that if you have redevelopment, you can lose some of the older buildings, which is a loss of sense of place. And we can also lose community character. This is a big issue for a lot of people, where you might have a kind of a smaller scale community that could also affect sense of place. And viewshed is often a thing that comes up with density. If people enjoy the viewshed, you don't want to have these massive buildings. So it was suggested in some of the interviews that you can densify in different ways. And as you can see, this laneway cottage approach, or having smaller buildings, infill buildings, might be an approach to be able to mitigate against that loss of sense of place. So we do have these models available, and we're hoping that people can use them for planning. But then the question comes in, well, how exactly can you use them for planning? Well, one of the ways that you can use them is they can actually be used to inform the design of community modeling exercises. So thinking quantitative modeling exercises where you're doing scenarios and simulations. If you're doing things around transportation systems and trying to model greenhouse gases, you can also think about the other connections and synergies between that and walkability, maybe think around metrics like that, and also green space. I'm actually doing this in Squamish right now, so I use these conceptual models as a basis. I find them incredibly useful. But in some cases, too, you might also find that not all of these variables are quantitative and these factors are quantitative. So in terms of sense of place, it's hard to measure that. So you can actually say that, okay, well, in this case, this particular scenario, we actually do reduce greenhouse gas emissions. We've got decent walkability, but hey, this is a qualitative consideration. So you can go back to that model and think about it. This might be a challenge. Also, you can think about other tools that you can use to assess this. And this is why I have this 3D visualization up there saying like, this might be a challenge. This is great for walkability and greenhouse gas reduction, but sense of place, this might be a challenge. So let's use another tool like a visualization to see if we can assess that better. The second one, and perhaps maybe this might even be more useful for communities, is that I think these can actually serve as good tools for community engagement. If you bring stakeholder workshops and you want to talk about different climate action strategies, then you can start looking at these connections. Once again, I find, as you can see from that model, they are relatively intuitive bit by bit. But in these discussions, you can say, hey, we're going to go this route. Look at the other benefits spring from this, or look at these challenges that we might encounter. So let's talk about how we can address these challenges. And even still, you can use it as a starting point for figuring out who you want to invite to the table. Some strategies might link to, for example, agriculture. So this way you can figure out who's involved in the local agricultural scene. I should mention that these models are in a form that you can edit in an open source program, YED, so you can tailor them to your own community needs. So that's co-benefits. The second project that we did, decomposition analysis, in essence, it's a way of breaking down and exploring the factors that cause a change in variable over time. So in this case, we're looking at emissions. Like a decomposition model, I'm not going to get too deep into the math there. This is the only formula I'm going to throw at you. These are kind of the main factors that you look at. A lot of decomposition analysis are done at the national level, and they'll look at energy and emissions for different sectors and industries. So giving that example, an overall activity factor would often be things like GDP. So that would be an indicator of economic activity for these in different industries. Then you have a structure factor. And what this will look at is like the GDP for various industries. So whether this is construction, agriculture, or forestry. So you're looking at the proportion of activity for the different industries and how that changes over time. And then activity intensity is for emissions per like GDP unit. So it's like the intensity of emissions being produced. So that's national level, and it's often these decomposition analyses have been done at national and state and provincial levels. What we wanted to do was figure if we can make this relevant to the local and regional level. We can bring this out to planners. So we created a couple decomposition models and ran it for Metro Vancouver. We used the community energy and emissions inventory data that is produced by the province. They only had 2007 to 2012, but still it worked well to explore if this is actually useful for planners, so it still worked well for our purposes. Created two models, transportation and residential energy, and as you can see here, the activity factor for both of them is the population of the region. In this way, we're saying the activity is how many potential emitters do we have? How many potential people do we have that might cause emissions? This first structure factor is the population of people living in different places. Are they living in an urbanized Vancouver or kind of a more suburban Port Moody place, right? So that could have different implications for energy use and transportation. And then we had an intensity factor that kind of varied between the two different models. Our first intensity factor was kilometers, how much people are driving per capita. And then for residential energy, it was energy customer accounts per capita. This was the data we had available, but we kind of use this as a proxy of thinking how many people are living within a household or how many people are living within one building. And then the structure for transportation was around what types of vehicles people are driving, and residential energy was around what sort of fuel are they using. Is it electric or natural gas heating? And then finally, we had an intensity factor of emissions produced for kilometers traveled and residential energy with emissions produced per energy account. In the interest of time, I'm only going to show you some results from the transportation, just gives you an idea of what we're looking at. Well, overall, in the transportation, Vancouver experienced an increase in emissions. And overwhelmingly, the thing that was contributing most to it was an increase in population. The population distribution factor showed very little change, actually, and it's very possible that this might just be around the spatial resolution. If we had data that just went down to the neighborhood level, we might actually see some changes, perhaps maybe with two cores, but ultimately that didn't give us too much information on what was contributing. But you can see now then we have these other factors where the driving intensity, people are driving less per capita or maybe more carpooling, perhaps those sort of things. Driving intensity actually led to reduction in GHG emissions. The types of vehicles people were driving, so people buying larger vehicles in that time period actually contributed to an increase. And then finally, emissions intensity contributed to a decrease. That one's not too surprising. Vehicles were getting more efficient over time. Now that's at the regional level. We also did this complementary analysis that does a community scale. So we're looking now for each of the individual cities. And this gives you kind of some more interesting information. It's something that kind of gives you a bit more insight. You can dig deeper into the data because as we noticed, the driving intensity overall led to a decrease in emissions, but it's not the same story for every community here. You can see those pale white yellowish areas right there of Lions Bay, Balcara, and more White Rock, these areas that can be kind of considered bedroom communities, they're actually showing a little bit of increase. So by looking at this, we can say, okay, well, as a region, these are where our challenges still lie. We can think about perhaps maybe enhancing the transportation network, or maybe this is something that communities also want to take on to densifying their own neighborhood nodes. The other thing you'll notice that in the areas where driving intensity contributed to a decrease in a mitigation sense, it was more so for certain communities like Richmond, Vancouver, and Burnaby, where Surrey and Langley didn't see the same sort of decrease. And this is interesting to us. It's saying like, okay, well, Surrey is also quite a big city, like, Richmond, Burnaby, and Vancouver. What's the difference there? Well, they're experiencing different challenges. Surrey and Langley have much more spread out cities. So, this kind of gives you insight on the planning challenges of these individual communities. And as a region, these are things that you might want to address and think about which communities might need a little bit of help and be more ambitious in their mitigation efforts. So what is it this can actually do for local planning? Well, this can provide insight on where progress has been made. So we do have that driving intensity. It doesn't exactly give you an idea of what is causing the mitigation, right? So a combination, perhaps maybe the BC carbon tax, better transportation networks, bike lanes. You sort of have to look at it as a collective, but you actually just generally get a sense of where gains are being made. Now, perhaps maybe more importantly, you see where the challenges are and perhaps where policies should be directed. So you look at the challenges around vehicle type and those increases there. So we think about a time around 2012. So what do we think about in terms of incentivizing smaller vehicles or electric vehicles? The last point I have up here is saying that I found the regional local scales, or we found the regional local scales were incredibly important, complementary analysis. They weren't substitutes for one another. Regional is good because, the Metro Vancouver, you cannot think of them as isolated communities. People work, live, and play and across the borders all the time. So it's important to look at it that way. But the local scale gives you kind of that fine tune to figure out where those other challenges are.